All right, today we're going to get our hands a little dirty. We're going under the car to really understand one of its most critical, but maybe most overlooked systems. We're talking about the incredible journey power takes from the engine all the way to the pavement. It's something you probably never even think about, right? You hit the gas, the engine roars to life, and the car just goes. But what's really happening in that space between the engine and the wheels? How does all that fire and fury turn into smooth forward motion? Well, that's exactly the mystery we're solving today. So, how does it all happen? Well, the answer is this amazing mechanical bridge that literally connects your engine to the road. It is the absolute critical link that takes raw power and turns it into actual movement. And it's called the drive shaft system. At its heart, the drive shaft system is basically a power delivery network. It has one job and one job only: take all that rotational force, what we call torque, from the engine and transmission and get it to the wheels so they can turn. I mean, without this system, your engine is just a really loud, expensive paperweight. Okay, so let's get into the anatomy of this thing. We're going to break it down piece by piece, starting with the absolute backbone of the system, the propeller shaft. Think of this as the long-distance runner of your car's drivetrain. The propeller shaft, or prop shaft as you'll hear it called, has to cover a lot of ground, spanning nearly the entire length of the vehicle. Its job is to carry a massive amount of torque really efficiently over that distance, and it has to do it all without twisting up like a pretzel or vibrating the whole car apart. And you might be thinking, it's just a metal tube, right? No way. Look at this diagram from a service manual. It shows two totally different designs: the 3UJ type up top and the DOJ type on the bottom. You can see they have different joints, different lengths. Every single millimeter is precisely engineered for a specific car, a specific weight, and a specific power output. So, if the propeller shaft is our long-distance runner, then the axles are the sprinters. They handle that final, super important last leg of the race, getting the power to each individual wheel. And right here, this is the handoff. It's like a relay race. The propeller shaft plugs into the differential, which then splits that power and sends it shooting out to the wheels through the drive axles. It's a perfectly seamless transition from one part of the journey to the next. Whoa, okay, I know what you're thinking. This looks like a total mess, right? Random jumble of parts, but what you're actually seeing is the entire front axle assembly, blown apart so you can see every detail. It's a symphony of engineering, with over 20 individual pieces all working together in perfect harmony. Let's try and make sense of this. First, you've got the hub and bearing. They're what lets the wheels spin freely. Then you have the joints, and this is where the real magic happens. These amazing little things let the shaft spin like crazy, even while the wheel is turning left and right, and the suspension is bouncing up and down. The rubber boots are there to protect those vital joints from dirt and grime. And the big one, the axle nut, is what holds the whole shebang together. And you'll see a very similar story when you look at the rear axle. It's just as complex. You've got components like the inner race, the cage, and tiny ball bearings all forming these incredibly precise joints that let the power flow smoothly to the back of the car. And here's where you see that this is truly a game of millimeters. Look at this table. For a non-turbo model, the shaft diameter jumps from 24.9 to 28 millimeters just by going from an automatic to a manual transmission. Why? Well, think about it. That small difference is a very deliberate engineering choice. It's there to handle the sudden, forceful punch of torque you get when you dump the clutch on a manual. Okay, so we've seen just how precise these parts are. That kind of begs the question, right? What does it take to actually work on them? As you can probably guess, this is not a job for your basic wrench and a hammer. It requires a specialist's toolkit. First up, bam, the axle shaft puller. This wild-looking device has one job and one job only: to safely and evenly pull the axle shaft out without breaking anything around it. Next in the arsenal is the hub remover. Again, it's a tool built for a single purpose. It applies precise, even force to separate the wheel hub, which is pressed on there with an incredible amount of pressure. And check this out, a drive shaft remover. It looks kind of simple, but this lever provides the exact leverage you need to pop the drive shaft out of the transmission without wrecking any of the delicate seals. It just goes to show, having the right tool is absolutely everything. And all of this, the complexity, the special tools, it all points to one final critical idea. When you're dealing with parts that spin thousands of times a minute and are handling immense force, precision isn't just a nice to have, it is non-negotiable. Honestly, the service manual reads like a surgeon's pre-op checklist. Every single bolt has to be tightened to a specific torque. You have to keep every part in order, protected from even a speck of dust. You have to use the exact type of grease they tell you to. Every single detail is critical for both safety and performance. Let's just take this number for example, 140 foot-pounds. That's the torque spec for the main axle nut. So what on earth does that even mean? Well, picture a 140-pound person standing with all their weight on the very end of a wrench that's exactly 1 foot long. It's not just tight, it's a specific, measured, and absolutely mandatory amount of force. This obsession with precision is everywhere. Before a technician even thinks about taking a propeller shaft apart, they make these little matching marks. Why? To make sure that when it all goes back together, it's balanced in the exact same orientation. Get that wrong by even a tiny amount, and you could create a vibration that will literally tear the system apart at highway speeds. So after peeling back all those layers, after seeing the intricate parts, the specialized tools, and the absolute demand for precision, it kind of changes how you think about just driving down the road, doesn't it? The next time you hit the accelerator, you'll know about the incredible journey of power that's happening right there, right underneath your feet.